Hello. Today I am going to set up a very simple server, to store and manage my passwords remotely. Using Pass, the standard Unix password manager. The server will sit in my local network, behind a router. And my goal will be to make it accessible from the internet. Both from desktop, and mobile. Using SSH. The cryptographic operations for encrypting and decrypting passwords are not going to occur in the server's OS memory, but on an external hardware security device. Ideally, you should use open source hardware. But for teaching purposes, I will be using a Yubikey. The reason being that even though Yubikeys are closed source, they are extremely popular and widely available all over the world. You can play and learn with them, until you get a more secure key. The same goes for Raspberry Pis. Widely available, but closed source. So beware. Anyway, this is the plan for today. In part 1, I will flash Ubuntu server into a micro SD card, and boot from a Raspberry Pi. I will set up the server, harden it, and prepare it for our purpose. In part 2, I will set up the Yubikey, and make sure that the server can communicate with it. In part 3, I will generate securely, and offline, a PGP certifying master key. This key will issue a subkey for encryption, necessary for our password manager operation. I will then flash this key, into the Yubikey. In part 4, I will install Pass, into the server. At this point, the password manager will be already functional and accessible, but only from desktop, and only within my local network. In part 5, I will make my server reliably accessible from the internet, by installing a dynamic DNS client. And in part 6, I will make Pass, accessible from my mobile. There's many other ways you could accomplish what I'm doing here today. There's even a very nice Android app. I want to maximize the versatility and security, by perhaps compromising a bit of convenience. I also want this setup to be as open-ended and as accessible as possible. So bear with me. The end result will be pretty sweet. You will see me run through many of the procedures that I have described. I have recorded full series about these issues. A PGP, GPG series. A Yubikey series, where you can watch a whole episode about Pass. So please check the links below. There's additional resources for almost everything I am going to do. Except for part 5. This is the first time I am dealing with dynamic DNS. Let's start. I will do this, from Linux Tales. I need to set up an administration password. Connect to the internet. And download and verify, the Ubuntu pre-installed image for Raspberry Pi, from, releases.ubuntu.com. Just follow the links. Everything is okay. Now I will flash this image into a micro SD card. Using the disks application entails I will insert this micro SD card into the Raspberry Pi, turn it on, and connect it into my home router. To know the IP address of the server, I will run the command, nmap update first, and then install it. I don't recognize this IP. SSH as the default user, Ubuntu, with the password Ubuntu. Provide a new password and try again. First, upgrade the server. Whatever hardware you're using, make sure it's up to date. Let's allow incoming connections only from SSH, and only from our local network, for now. Install fail2ban, to protect SSH from brute force attacks. Change your host name to SS. You will understand later why that is. Let's create a user called P, with no password. This is the user that I will use for running pass. I will reboot the server, and move to my Linux daily driver. I am going to generate some SSH keys to access the server. Type RSA. Maximum size. Move your pub key into the server and try logging in. Great. I will copy my keys into my past user's home directory. And edit the SSH configuration file. Disallow root login. Allow only Ubuntu and P to access the server. And disable password authentication. I will log out, and write a config SSH file, specifying 2 hosts. One of them is going to be a user for administration, such as installing packages, upgrading, rebooting and so on. The other one, the regular pass user, without sudo privileges. Let's test it. Okay. So let's start working on the Yubikey. First I need to make the pass user be a member of the plug dev group, so it can have access to the USB ports. If you want to play it safe, install all these packages to make sure that your server will be able to talk to the Yubikey, no matter what. Now insert the Yubikey into your server, and type the following command. Everything is okay. A factory reset Yubikey. Edit the card. First thing to do is to change the default PIN and administration PIN. The default PIN is 123456. The default administration PIN is 12345678. And since the Yubikey is going to be permanently plugged into the server, use the Yubikey Manager to make sure that the touch policy for the encryption key is off. By that I mean, that the key does not require physical touch to perform that cryptographic operation. This is how you toggle this feature, on and off. Okay. We're almost done. I need to fix one final issue. Let me reboot the server so you can see what it is. On reboot, the server cannot detect the Yubikey. The easiest fix is to unplug it and plug it back in. Obviously that's not a workable solution for us, because our goal is to make our PAS server accessible from the internet. The easiest solution is to restart the PCSC smart card daemon. So I am going to write this command into a bash script, and make it always run on boot, by creating a service. The script will be at user local sbin. Don't forget to make the script executable. Now I will write the service. Enable it, and let's see if it works. Perfect. Now let's generate some keys for our Yubikey, securely, and offline, in Linux Tails. Okay. First, delete the existing GPG data directory. Create a certifying PGP master key. Now issue a subkey for encryption. Insert your Yubikey and flash the encryption key into it. Great! My Yubikey now holds a PGP key for encryption. Now I will store the master password and my public key in a directory inside the GPG data directory. Before backing up and shutting down, I need to move the public key out of here. I could use a USB drive or an SD card. But since these keys have been generated offline in an air-gapped computer, I don't want to connect any additional devices if I don't have to. And I don't, because I can transfer the public key, encode it into a QR code. Let's try that. I get an error, because I cannot fit so much data into a QR code. An easy fix is to split the PGP armored file in half, and generate 2 QR codes. The file is 51 lines long. With the command said, I can encode the first 25 lines into a QR code, and then send it to a file. And again, for the remainder of the file. Having these files is useful, because I can easily show them in full screen. I'll move to my regular PC and scan them with the zbarcam command. If you don't have it in your system, install the zbartools package. I'll scan the Linux Tails screen with this laptop's webcam. Now I'll switch to the second QR code. Got it. Press Ctrl+C to stop scanning. Before shutting down Tails, make sure that you back up your GPG data directory into a USB drive. Save your public key into a file. And copy it to the server, through SSH. Now log in as the Ubuntu user, and install PAS. Log in as the PAS user, import the public key, and trust it ultimately. To initialize a new password storage, you only need to know the fingerprint of your master PGP key. There's my data directory and my GPG ID file. At this point, PAS should already work properly with our Yubikey. Let's reboot and test it. Log in as the PAS user and create a password entry in PAS. Now try decrypting it. It works. I am asked to unlock the Yubikey to perform the cryptographic operation. Let me add a few more random entries. Okay. There's something I want to hack, before moving on. Notice that when I try to decrypt another password, the Yubikey is already unlocked. And it will stay that way until the device is removed from the USB port, or the system is restarted. This might or might not be desirable when you have constant physical access to the device, but I want to have the option to make the Yubikey lock itself up, thus requiring the PIN to be able to decrypt passwords again. You can force the Yubikey to unlock itself, by restarting the GPG agent. I am going to define an alias for this command in the bash rc file, so we can perform this operation easily and at will. I will call it forget. Source the bash rc file, and you can start using it. We already have a functional PAS server. Now let's make it accessible, from the internet. So this is the issue with running a server behind a regular home router. You are connected to the internet through an ISP, and chances are that you are not paying the extra fee to have a static IP address. That means that whenever you reboot your router, or whenever your ISP wants, your home IP changes. This is where dynamic DNS service providers come in. I am going to install a client that will feed my current IP to a server in real time. This dynamic DNS service also knows about a domain that I control, and is live on the internet. With these two data, it will broadcast a type A DNS record, pointing my domain to my IP, thus making the server always available outside my local network. If my IP changes, the DDNS client will push the new address to the server, and the A record will immediately be updated, and so on. I am going to use dsec.io. On top of the dynamic DNS service, I can also get a free domain. So create an account, and get a domain for yourself. If you want to see me do it, please check the link in the description. These are the credentials for my dsec account. My domain is pass.dyn.io. When signing in, I got an authorization token. My dynamic DNS client will need it to push my IP changes into their server. And of course I had to provide an email and a password for logging in. Since PAS is already working in my server, I will create a multi-line entry for my dsec account. There it is. My domain. You don't have to do anything else. When you run the dynamic DNS client in your server, a type A DNS record will automatically be created under your domain. So, log in as the administration user. And install DD client. Select Dynamic DNS 2. And it doesn't matter if you fill these fields or not. I am going to write a configuration file from scratch. The configuration file is situated at etc. Replace it with this. you have to fill in your actual domain. And the key for accessing your account at the DNS server. Restart the service that runs DD client, and make sure it's enabled. This is very important. Please make sure that DD client is running with the daemon flag. If it isn't, go to the configuration file situated at etc default. Add it manually, and restart the service. If you go now to dsec.io and click your domain, you'll see a new type A DNS record, containing your home IP. Now I should be able to SSH into my server, not from my local network, but through the internet. Let's test it. It doesn't work. But I will give you a few seconds to guess what the issue is. My server's firewall is set up to accept incoming connections to port 22, only from my local network. I need to replace that firewall rule, to allow SSH incoming connections from anywhere. Try again. Success. Now I can access my PAS home server, from anywhere in the world. The content of your domain's A record, at dsec.io, will match at all times, the output of either one of these two commands. Your home IP address. Let's do a final check and log in, as the PAS user. Let's keep this as simple and versatile as possible. Download Termux, a Linux terminal and environment emulator. First, upgrade. Install OpenSSH. Create a key pair to access our server. I will move the public key to the server, using a QR code. From now on, I can SSH using my phone. I will make it easier, by adding the PAS server as a host in the SSH config file. Let's try it. And I am in. I will test it by logging into my DSEC account. You won't be able to see much, because the Tor browser doesn't allow screenshots nor screen capture. But you will get the idea. And I am logged in. The cool thing about this setup is that I have full control over pass, both from mobile and desktop. Let me create one final entry to my password storage, from my phone. And my home pass server is updated. Centralized. With strong cryptography. But without trusting a third party. And you can back up easily from desktop and mobile. Just copy the backups through SSH. And store them locally, on your device. I encourage you to try this setup. It really feels way cooler than it looks. Until next time.